Hello, the topic of the lesson is recursion. Recursion is a way of achieving repetition besides using loops. So we know we can use loops to achieve iteration, but we can also use recursion to achieve repetition to solve a problem. The motivation of writing recursive function is that many programming tasks are recursive in their nature. Okay, for example, the factorial numbers, Fibonacci numbers, and the famous Tower of Hanoi challenge. Writing recursive functions often results in simple and elegant solutions in comparison to their corresponding non-recursive solutions. So what is a recursion, or what is a recursive function? Okay, the recursive function is a function that solves the problem by calling itself. So before we discuss how to write recursive functions, let's first take a look at a normal function calling process as illustrated in this page. Say we have three functions, function A, B, and C, and the program starts from the execution of function A. Okay, so that's the start of function A, and somewhere inside function A we call function B, and therefore by the order of execution the flow jumps to the beginning of function B. And then suppose say somewhere inside function B we also call function C, and then the flow jumps to the beginning of function C. And function C does not call any other functions, so we simply go through the statements in function C and from the beginning to finish. When function C is finished, it jumps back where C was called in B. And then a B function carries on until the end and jumps back where B was called in function A. And then function A carries on till the end. So that's the normal function calling process. Now let's look at how a recursive function is being called. Okay, this page says we have a function A, which is a recursive function. Okay, and then from the beginning of the function A, we just carries on, and somewhere inside of this function, the function A itself is being called. And therefore, based on our previous discussion in this page, when you call a function, it jumps to the beginning of the function and it carries on. Okay, in this case, it jumps to the beginning of this function itself and execute another round of function A. And then inside that function A, in that function call, we also calls function, and it jumps back, and then calling, jumps back, calling, jumps back. So as you can see, if we allow this recursive function calling process to carry on, it would be infinite. Okay, just like infinite loops. We do not allow infinite loops to happen. Same thing in here, we cannot allow this recursive non-stop function calling process to keep going. So, and therefore, we need to put this calling of the function itself under a condition. So that's what we do. So we put an if statement. Okay, so if it's done, and then we do not call the function itself, so we just simply bypass, skip the function call, and carry on until finish. If it's not done, else, and then we call the function itself, and it goes back. If it's still not done, means else, we call it again, and as soon as the problem is solved, job done, and then we just jump to the end and bypass the calling of the function itself to finish the recursive calling process. So we call the if case the base case, means the base case does not call the function itself, bypass it. The else case, we call it is the recursive case, meaning when the else condition is met, we call the function itself to start recursive calling process. Okay, so that's basically how we write this type of recursive function in this lesson. So what we're gonna do is we're gonna take a look at an example of recursive functions. Okay, the function we are going to write is simulates the process of counting down from a number. Okay, so it takes, say we name this function countdown. Okay, it takes an integer as a parameter and displays one number at a time until 1, and then after that would be the word blast off. So it's simulates the process of launching a rocket, space rocket. Okay, now based on what we discussed before is that when this number is less than 1 or equals to 0 or less than 0, let's say if it's 0 or any number less than 0, and then we do not display those numbers, we simply display the word blast off. That's our base case. So the basic case is that we do not have to call this countdown function itself inside the function. We simply display the word blast off and finish. So that would be our base case. So if this number is less than or equals to 0, so in that case we simply output the word, say, blast off. Okay, so that's our base case. We put it in here, so that's the base case. All right. And if this base case is not met, it means that the number n is greater than 0. In that case, it's the else part. And we say this is our recursive case. In the recursive case, we're going to rely on this countdown function itself to solve the problem. But all we do is that we display the number n itself, display this number n, and then we pass the number countdown n minus 1 to the countdown itself. So we inside this countdown function, we call this countdown function itself by passing one number less than the original number to the function. Okay. So first of all, before I explain this how this function works, first of all, let's call this function in the main and pass the number 5 to it. And what we expect is that we're going to expect this program will display 5, 4, 3, 2, 1, and blast off. Okay, Control F11. As you can see, it's 5, 4, 3, 2, 1, and then blast off. Okay, how does this function work? Okay, first of all, let's say we'll pass 5 to this function countdown. So n equals to 5. And because 5 is not less than 0, so we go to the else part. And then we output 5 in here. And then we call the function countdown 5 minus 1, which is 4. So countdown 4. So 4 is passed to this function itself. And because 4, and then we start executing the same code again. So 4 is not less than 0, so we go to the else part again, output 4, and then count down 4 minus 1, which is 3. And the 3 is passed to this function itself. 3 is still not less than 0, so we go to the else part, output 3, and then count down 3 minus 1, which is 2. And again, goes to that, jump to the else part and output 2, and then count down 2 minus 1, which is 1. So 1 is passed to this countdown function, and 1 is still not less than 0, so we go to the else part, output 1, and this time it is count down 1 minus 1, which is 0, so count down 0. And then 0 is passed to this function because 0 is equals to 0, so the if case is met, base case is met, so that we output this blast off and then finish. So we're no longer calling the function countdown itself when n becomes 0. That's basically how this recursive function works. Okay, now from the discussion of this countdown function, we can summarize the rules of writing recursive functions. First of all, there must be a base case. Okay, within a countdown within a recursive function, there must be a base case where the the function itself is not called. Okay, so that's base case is the stop case or the exit case. So we say that's the stop case that stops the recursive calling sequence or the exit of the loop, if you like. Okay, that's the first rule. Rule number 2, there must be a recursive case. Okay, there must be a recursive case because after all, a recursive function relies on calling itself to solve the problem. So there must be a recursive case where the function itself is called. And that's number 2. But in this rule number 2, okay, the recursive calling condition, in this case n-1, recursive calling condition must progress towards the base case. What that means is that here we pass n-1 to the countdown function itself, and because n, the number passed to the countdown function is getting smaller and smaller, and therefore it eventually will make this base case true to stop the calling process. Okay, suppose, let's say we use a different calling condition for this recursive case. Say, for example, if we just put n in here, and then when we run it, we'll see this number. Okay, we'll see this 5555555. It's actually a infinite calling process. Okay, now, the reason for that is because this calling condition n is not progressing towards the base case. It's not getting smaller and smaller. It just remains 5. Okay, so this one would be incorrect calling condition. Okay. Another incorrect calling condition is like this. Say we pass to the countdown function n-1 instead. Okay, so in this case, when you execute this recursive function, as you can see, the number is getting larger and larger and larger. Okay, going against the direction of the base case. It will never make the base case true. So that is also another case of not progressing towards the base case. So both n and n-1 does not progress towards the base case or making the base case true, therefore to stop the recursive calling sequence. Okay, so to summarize this, the rules of writing recursive functions. Number 1, there must be a base case, which is the simplest case or the stop case. exit case. Okay, where the function itself is not called. Okay, so that's the base case here. Number 2, there must be a recursive case calling the function itself the where the calling condition must towards the base case. Making the base case the calling parameter. Okay, so let's summarize this again. The rules of writing recursive functions is that there must be a base case, which is the stop case and exit case, where the function itself is not called. Okay, that's our base case in here, the first one. In this base case, we do not call the function countdown itself. Secondly, there must be a recursive case. That's the recursive case, where the calling parameter must progress towards the base case, i.e. making the base condition true. So because we are passing a smaller number to this countdown function, eventually we'll make this if condition true. Okay, so that wraps up our topic discussion today. We'll see you all in next video.